Hello everyone. In the previous video we had an introduction to pointers and hopefully they don't seem too bad. In this video we're going to talk about some of the indirect properties that they can have on other variables, especially the variables that they point to. And we will go through an arithmetic example. So first let's set up an example in which we're going to do an indirect change. We'll aptly name indirect change.c. So I'll start this program off by creating, let's say, a float called u. I'll give it a value of 0.5. And then I'll create a pointer to u, a pointer to a float called t. I will set t equal to the address of u, which makes sense. So now t is a pointer that points to u. When I dereference the pointer, I can access the value at the address that it points to. But what happens if I try to modify it? So if I dereference t and I set that equal to, actually, let's multiply it. Multiply equals, I don't know. Let's multiply by 4.2. What happens if we print the value of t? Well, we can just do %f, and we can just dereference t. We need to have our ending statements. GCC, indirect change. If I execute it, okay, 2.1. So we get an answer. So what happens if we print our variable u? What happens if we go and we print u? What do you think will happen? Well, there's really only one way to find out. So it seems that u got changed as well. And it seems that when we change a dereference to a variable, it changes the value to the variable itself. Let's go back to the code. Right, so we have a variable u, and then we have a pointer called t. We then point t to u, meaning that t is a pointer to the variable u. So then we modify t by dereferencing it. Right, so we dereference to access the value at u, and we modify that value. So it turns out by modifying that value, we're indirectly modifying u. And that's pretty cool. But that could also be very dangerous because editing that can have unintended consequences. But if you use it correctly, it can make your code easier to use and more efficient. Right? It can also save you a lot of space in your program, which us programmers need to do. We always need to save space. So the use of dereferencing and the fact that it can edit variables permanently by indirect change can be a useful tool, but also a dangerous one. Now let's go to our next example. So now what we're going to do is that we're going to show that, well, with pointers and using their values, it's just you can use them like variables, and typically that's what you do. So we can edit a file called pointer math, and what pointer math will do is that it'll set up some variables and we'll do some arithmetic on them. And here we are. So on lines 4 through 6, I create 3 variables, x, y, and z. On line 8, I create a pointer to an integer and called x pointer, and I have that point to x immediately in one line. On line 9, I have a stylistically different way of creating a pointer, but it effectively does the same thing. I create a pointer to a float and I have it immediately pointing to that float variable. Then on lines 10 and 11, I declare a pointer called z pointer, and then in the next line I have it point to the variable z. So in line 13, I do a summation. The third variable that's being used in printf, which is going to be this, let's highlight it. is going to be the sum of a dereferenced integer, a dereferenced pointer to an integer, plus 5. Right? So x pointer points to x, so when I dereference it and add 5 here, it'll take the value of 17 and add 5 to it. Notice here that this is different from our previous program where we were writing to x to a pointer. Here we are just dereferencing it and using it. We're just reading that value. We're using it locally, so we're just reading the value. So here the difference between this and the previous program is that we are not modifying x pointer because we're not setting it equal to something. The next example is a little bit more confusing because I have a dereference to a float, which is dereferencing y pointer, and then I do the same thing with a double pointer, but then here I do a multiplication. I dereference y pointer and z pointer, and I have to put them in parentheses because the multiplication symbol, which is the asterisk, is the same as the dereference symbol. And could you imagine if I had something like this, or even crazier, something like that? What does that even mean? Is that a double multiply? Is that a dereference and a multiply? Or is that even like a double dereference? Which you can do. It gets a little bit more complicated, but you can do a double dereference. So it's not exactly clear to the programmer or the compiler on what's going on. So if you're doing something that has multiple asterisks, whether you're doing the multiplication of dereference pointers or something like that, it's best to use parentheses. So that way you can clearly state your intentions. And then on the next line, we also have a division of an integer pointer that's been dereferenced with another that's being divided by a pointer to a double that's been dereferenced. So why don't we run the code for that? Feel free to go and verify the math on this. This example is not exactly normal, meaning that it doesn't really have a lot of utility and it's not really used. Pointers aren't really used in this manner, but I think it's important to highlight that pointers are used like variables, and that's what we use them for. The actual implementations of many pointers are a little bit more abstract, but here the principle is the same. In the next video, we're going to cover pointers and how they relate to characters and strings. Thank you.